Morning, this is your math sensei, Mr. Spensei, and this is STAAR Test 2024, problems 12 through 21. So it says, what is the solution to the linear inequality y is greater than or equal to 1/2 x minus 2? Graph the solutions. First off, before we get too far, I want to pay real close attention to this because this will get us our first part of our answer. It says greater than or equal to. Anytime you have a less than or equal to, a greater than or equal to, or an equal to, you end up with a solid line. So we know that we're going to end up, when it asks for the line type, we're going to be looking for a solid line. On the other hand, now they didn't ask this, but had they given us less than or greater than without a line underneath, it would have been a dashed line. So this is going to be a solid line and means anything that's on the line actually counts. Dashed line, if it's on the line, it doesn't count. But this is a solid line. So then we're supposed to graph this. Well, we have a couple ways to go about doing this. I'm going to do this first with Desmos. Now, Desmos won't let us use the inequality. We're going to have to do that. We're going to have to use an equal sign here, but that will get us our graph. And please notice, we have to be in y equals mx plus b form, where m is my slope and b is where it crosses the y-intercept. So m is my slope, b is where it crosses the y-intercept. So in this case, we know we're starting off, b is at -2. And I'm going to graph it by hand first. So b is at -2. And my slope is 1/2. Well, remember, it's y over the x's. So that's up 1 over 2 because it's positive. So up 1 and over 2. And we can drag this and just keep going like that. And if we continue the pattern, it goes something like this. And we said that it gets a solid line in using this note card. Pretty dirty little note card, but there we go. Disgusting little thing. There's our solid line. Now, I can do that same type of line using Desmos. So let's show you how to do that. So I'm going to press the share screen. And I'm just going to type in y equals 1/2 x minus 2. Y equals 1/2. There's my fraction, x minus 2. And we can select a couple of points. We can select 0, -2. Go ahead and label that. And we can select that point, which is 4, 0. So I'm going to mark those 2 points on my paper and see if I actually hit those. So 0, -2, where 0 is my x, and I end up with also 4, 0. So I'm going to stop that. And I should have a 0, -2. Well, there's 0, -2, and I should have a 4, 0. There it is. So those are the 2 points that I'm going to use, and I got them straight off of Desmos. Okay, we have a greater than. Well, I always like to picture this guy. I act like this is a tree, and the tree is going to fall down. Well, if it's going to fall, is it going to fall to my left, or is it going to fall to my right? And you're going to go, no, it falls like that. So I have this guy. I have one guy here, and I have one guy up here. If the tree falls down, it falls on that. That means this guy is less than because he's below. Well, in this case, we had a greater than, so this guy is greater than. So we're actually shading, we're shading up here because this is in the greater than zone. So we're going to shade above the line because it's a greater than, whether it's a greater than or equal to. And we would have shaded below the line if it had been a less than or equal to. All right. So the guy lands on top of the tree because he's above the tree, he's above the line. Now, the other way to do this is we can use the calculator, and you'll have access to the calculator, in which case you'll press the y equals button. And I'm going to press clear and get all that stuff out of there, or try to. Now, this is a little bit more complicated and you may not want to use it, but our equation is y is greater than or equal to 1/2 x. So 1 divided by 2, press the x button, and then minus 2. Okay, and if I hit graph, I get this graph. Oops. Okay, now I need to arrow over to the left and press enter. And I don't care what color it is, but what I do care about is this. Well, this is less than because it's pointing down, and this is greater than. So I need to change that direction. Now I have the greater than because it's pointing up, and I'll press that. Now that I have that, I go to OK, arrow down to that, press enter, and I press graph, and there it is. And that gives us the same graph that we already had. Now, I personally think Desmos and just knowing which way to shade is easier. So anyway, we needed a solid line because we had a line underneath, and we're shading above because it's a greater than symbol, and we got these 2 points. We got the 0, -2, and the 4, 0 are X and Y from Desmos. Okay, number 13. This is a difficult question. If you know how to do matrices, it's easy. If you don't know how to do matrices, this is a bit tough. So 2 customers purchased coffee and donuts at a coffee shop. Each cup of coffee costs the same amount. Each donut costs the same amount. The first customer paid $4.90 for 1 cup of coffee and 2 donuts. So we have 1 cup plus 2 donuts equals $4.90. That's my first equation. The second customer paid $8.60 for 2 cups plus 3 donuts, and they paid $8.60. Well, here I have 2 equations and 2 unknowns. Now we can solve this by substitution or elimination, etc., but I'm going to solve it by matrices. So this is one of the ones where you're going to want your calculator if you know how to do matrices. So here we go. We're going to press clear. And the very first thing I'm going to do is I'm going to press the press the blue button. Then I'm going to see where it says x to the -1. Above it, it says matrix. So blue matrix. I'm going to do that one more time. The blue button in matrix. Now I'm going to arrow over the word edit and press enter. Well, in this case, I have 1, 2 rows and 1, 2, 3 columns. So I need a 2 by 3. So 2, enter, 3, enter. And then I'm just going to put in the numbers. 1, enter, 2, enter, and 4.9. Then 2, enter, 3, enter, and 8.6. Okay, now that we've done that, we're going to leave the matrix. To leave the matrix, we're going to press blue matrix, arrow to math, drop down to RREF. Excuse me. Blue matrix, math, letter B, RREF. Press enter and press blue matrix one more time and enter twice. Now, we end up getting, the last column is our answer. So we end up getting 2.5 and 1.2. Well, what came first? C came first, coffee, and then this came as donuts. So coffee costs $2.50 and donuts cost $1.20. And they asked, what was the question? What is the cost of 1 cup of coffee? 1 cup of coffee is $2.50. $1.20, which they tried to trick you with, is our donut cost. But our answer to number 13 is A. Okay, moving on. Number 14. The graph of a linear function is shown. Which graph best represents the relationship shown in the graph? Okay, so we got a couple things here. We probably should find a couple pretty points. In other words, where it crosses the graph perfectly. And I'm like, you know what? It crosses perfectly here. And by the way, there's more than one way to do this. But those are 2 good points. Well, this point right here is negative 3 comma 0. And this point right here is 0 comma negative 5. So don't forget, these are my x and y's. Now that I have those 2 points, I can actually go to Desmos and put those in. Now, this isn't the only way to do this. I could put every single one of these equations in and see which one works. So I'm going to first put this in and see if you like that. And if you don't like that method, then we'll put every equation in to see how this works. So I'm going to go to share screen. I'm going to clear this out. Plus button gives me a table. And my first point was negative 3, oops, and then 0, and then 0 and negative 5. Hit the domino button, and there's my equation. Y equals negative 1.6667x minus 5. So I'm going to write that down because we know that that's our answer, or one of our answers. So y equals negative 1.667x minus 5. So I'm going to stop my share. And by the way, we can sit there and test that out. There's one of the points. And here's the other point. Okay. So we're going to stop the share. And we have y equals negative 1.667x minus 5. Well, I don't see that answer exactly, but one thing I do notice is minus 5. And I notice minus 5. That gets rid of this answer and this answer. Now we're down to, hey, you know what? Let's figure these out. The one thing Desmos doesn't do is it doesn't like turning those into um, fractions. So let's take the negative 3/5. Negative 3 divided by 5 gives me negative 0.6. That's not what we needed. We needed this. So if I try negative 5/3, negative 5 divided by 3, I get negative 1.667. Negative 1.667. That means my answer choice is C because that was wrong. Now, that's one way to do it. The other way to have done it is I could have put these equations into Desmos. So let's do that. So I'm going to switch back over and I'm going to go, which equation actually matches? So you can look at it and just match the graph. So I'm going to move over. And our first equation is y equals negative, 3 divided by 5, x minus 5. And look, we're not crossing at the right spot. So that's not it. The next one is negative. The only thing changed is this became a 3. And once again, we crossed here, which is good, but we're supposed to be at negative 3, 0. So not that one's not doesn't work either. So then we try the next one, which is also minus 5. But instead of this, this was a 5, and this is a 3. Now look, we're crossing at negative 3, 0, and we're crossing at 0, negative 5. I'm going to go ahead and mark those points because those are the points that we already marked on our graph. It's like, oh, those points match the ones we have on the graph. We obviously graphed it in the right spot. Okay. So we already know that our answer is C. We're done with that one. Number 15. Two hikers began hiking at the same time from different locations on a trail. The system of equations graphed on the grid represents the situation. Okay. Which value best represents the number of hours the two hikers have been hiking when they are in the same distance? All right. So for them to be at the same distance, they got to be at the same place. Well, where are they at the same place? I'm going to say it's somewhere right about here. And they're looking for hours. But since they're looking for hours, that means we're looking for the x-axis. So I'm just going to draw a line straight down. Okay, somewhere between 1 and 2. So it looks like less than 1.5, but somewhere between 1 and 2. Well, 2.8, no, too big. 2.5, too big. 4.5, too big. So the only one that's between 1 and 2 is 1.3. So the answer is B, because it's basically this is our answer. 1.3, oops, 1.3 hours and about 4.2 miles. But what we cared about in this case was the number of hours, right? So moving on to so the answer, I'm sorry, no, answer number 15 is B. Number 16, which function is equivalent to this? Okay, yes, we can go through all the factoring, but the easiest way to do is to plug this into Desmos and then plug every answer choice, and we're going to look for the answer choice that lays directly on top of this. So I'm going to go in and start plugging this in. We're going to get a quadratic. Now, I know it's going to be a parabola because this is raised to the second power, so it's going to be something shaped like this. It could be shaped like this, but because this is positive, I know it's going to be shaped like this one. So I'm going to start plugging this first one in, and then we'll plug these in to see which one is exactly the same. Okay, clearing this out. And we have 6x. I go to the little typewriter down here, press the squared button, minus 23x plus 21. So there's my first parabola. And we'll start off with A. And it asks for, make sure you always use parentheses, 3x minus 7, and then 2x minus 3. And it turns out this black one I'm going to lay directly on top of the purple one, so our answer choice must be A. So we know it's going to be A, but just to show you the one that doesn't work, I'll do the one below. I'm going to do a couple of others just to show you that they don't work. So keeping the purple one, because that's our original, we're going to go 3 parentheses x minus 1, and then we're going to put in 2x minus 7, and we can see that the red one does not lay directly on top of it, so it can't be B. Going to the next one. And the next one is parentheses 6x minus 7. Oops, that's a mess. Try that again. Erase all that out there. 6x minus 7. And then x minus 3. And once again, it doesn't lay on that one, so it can't be C. Then we go to D, which will be our last one. 3, and then we have parentheses x minus 1, and then we have 2x minus 7. And once again, it doesn't lie on directly on top of it. Okay, so can't be those answers. The only one it can be is A. So 16 is A. You know what? And I'm going to put that back in so you can see it. So this is going to be parentheses 3x minus 7. Three x minus 7, and then 2x minus 3. And once again, the blue one lies directly on top of the purple one. So the blue letter A is our answer. So the answer number 16 is A. Gotta fix that. typo on part D. 17, a part of an exponential function is graphed on the grid. Anytime we have an exponential function, I always want to go through this because this is super important you know this. Our exponential is y equals a b to the x. A is our start. It's also our y-intercept. B, if it's greater than 1, we have growth, which means it increases. If B is less than 1, we have decay, which means it is decreasing. Well, when I see this, I don't know what A is because I don't know where it's crossing the y-axis, but I know this, it's increasing. So I already know that when I look at this, it's going up. So I know that B is greater than 1. We have an increase. So it says, which two statements are true about the domain and range? Ooh, so this is domain and range. So remember, domain is our x values and range is our y values. So the domain. Well, if domain is the x, we're going to draw a line to the x-axis. Well, this is the domain, so our domain is going to be 2. And by the way, we have a solid endpoint. Anytime you have a solid endpoint, it's going to be one of these symbols. If it's a hollow, which it's not, but for a hollow, it's this. But since it's, or if it's an arrow. So in this case, we have 2 is less than or equal to, our domain is our x, is less than or equal to 5. So the domain is a set of all real numbers greater than or equal to 1 and less than or equal to 8. Nope. We're looking for 2 and 5. The domain is a set of all real numbers greater than or equal to 2 and less than or equal to 5. Bing, bing, bing. That's correct. But we got to slow down. Can't forget this. It says select 2 answers. So we selected one, we need to find the other. So now we have to go back and do the range. Well, the range is the y values. So what is our range? Well, we need to draw a line to the y-axis. Well, if I'm drawing a line to the y-axis, I'm going to have one here. And once I'm going to have a solid dot. So my range is going to be, when we start at the bottom, 1 is less than or equal to y is less than or equal to 8. So this is a domain, so we don't need it. The range is a set of all real numbers greater than or equal to 1 and less than or equal to 8. 1 less than, oh, 8, that's it. So our answers to 17, we have 2 answers, and they are, for 17, our answer choices are B and D. Number 18. The function g is defined by this. What are the solutions? When they're asking for the solutions, and by the way, I know that this is a quadratic because it has a second power. That means it's either going to be shaped like this or it's going to be shaped like this. The solutions are my zeros or my x-intercepts. All right, zeros, x-intercepts, sometimes they'll refer to them as the roots. Those all mean the same thing. Now, please remember, g of x just means that saying y equals 0. So we're going to graph both of these, and we're going to see where it intersects, and that's going to give our answer choices. But we're going to have a little bit of a problem. These are decimals. And we already know that Desmos doesn't give us these are fractions, and Desmos gives us decimals. So let's turn these answers into fractions. So 3 divided by 5, we turn those fractions. This is 0.6. Then I go 5 divided by 3, and I get 1.667. And then negative 3 divided by 5, and I get negative 0.6. And then we have negative 5/3. Negative 5 divided by 3, and we get negative 1.66. All right, just a moment. So now that we have that, what we're going to do is we're going to input this the 3x squared and the y equals 0. We're going to input those two equations and see where they cross. And where they cross, that's going to give us our answers. So I'm going to go ahead and share my screen. And the parabola equation was 3x squared minus 2x minus 5. And the next one was y equals 0. Well, this is where they cross. And I'm going to label that point. And the other place they cross is right here. And I'm going to label that point. So it crosses at negative 1, 0. And then it also crosses at 1.667, So those are my answers. So I need to go check my sheet to find out where that is. Well, all of them have the negative 1. Okay, so that didn't help us out. But then we have 1.66. Well, the one that has 1.66 is letter B. Make sure you don't choose D. D is a negative. We need a positive. So the answer to number 18 is B. Moving on, number 19. The table represents some point of an exponential function. Here's the key word. They told us this is exponential and they gave us a table. Which function represents the relation shown in the table? Okay, first off, every time we have an exponential, I want to talk about it. Y equals a b to the x power. A is my start. It's also my y-intercept. B, if it's greater than 1, we have growth and it increases. If B is less than 1, we have decay and it decreases. Well, my y-intercept is where it starts, and that's where it's going to be 0. So 32, this should be my A. Okay? So let's go ahead and enter this data into the table by go to Desmos, and we're going to select exponential. So we're going to go share this, and I'm going to enter that table. Make sure you enter the entire table. And we hit the plus button, select table, and we have 1, 2, 3, 4. Oops, that's wrong. Gotta delete those. What did I do wrong? I put them on the wrong side. Those are my X's. Having trouble making a delete. There. And back. And here we go. 1, 2, 3, 4. And then we had 48, and then 72, and 108, and 162. We're going to hit the little domino button that says add regression, and it gives us a linear automatic, but that's not what we want. We have to choose the exponential because they told us it's an exponential. So I'm going to zoom out so we can see this thing. And so there's our graph. And if we notice, we have 32, y equals 32, 1.5 to the x. So I'm going to write that down. Y equals 32 parentheses 1.5 raised to the x power. And now we're going to go back and look at our sheet and see if we can't figure out our answer. So right away, we know A is 32. So that gets rid of this one and this one. And I need 1.5. Well, unfortunately, this always gives me fractions, so I need to turn it into a decimal. What's 2 divided by 3? That's 2/3. So this is 0.66. And I needed 1.5, so this doesn't look very good. Then I go to 3 divided by 2, and I get 1.5. That matches. Our answer choice to number 19 is C. Number 20, which situation best represents association but not causation? Association just means there's a relation, all right? So we want a relationship, so there needs to be a relation between the two variables, but one is not causing the other, all right? One thing is not causing the other. There is a relationship, but one does not cause the other. Okay, when the number of spectators at a football game increases, the number of wins for the home team increases. Okay, is a relationship between winning and the number of spectators? Yeah, we definitely have a relationship because if a team's winning, more spectators show up. But does more spectators make the team score more points and win more games? No. So the number of spectators does not cause the team to win. There is a relationship because we like to go to watch winners, but it does not cause it. So there is an association, but not a causation. So this looks pretty good. This looks like this does that. There's a relation, but the number of spectators does not cause the team to win. Number B, when more gallons of water are put into an aquarium, the weight of the aquarium increases. Well, the more water you add, there is a relationship between them. As you add more water, it causes the aquarium to increase. But we're not supposed to have causation, so this one won't work because it causes it to increase. When the amount of time an athlete run increases, the distance they run increases. Well, the longer you run, uh, as you increase the time, your distance increases. So the amount of time causes the distance to increase. So that's false because we don't want a causation. When the charge of a cell phone battery decreases, so as battery decreases, the number of minutes can be used increases. That's false. There is no relationship. Battery decreases, the number decreases. So that's false. So 20, best answer choice is A. That's a tough problem. If we don't get that one, we'll still pass this test. 21, the quadratic function is transformed to create a graph as shown on the grid. What is the equation for G? So what we care about is not F, we care about G. So I need to know which of these makes this. All right. So how do I make this into G? And one of the things that's missing, I have a typo here, the quadratic function, and it should have been f of x equals x squared. That should have been on your paper. I apologize that it's not. So that really means every time I see an f, I need to put a squared. So this is going to get a squared, this is going to get a squared, this is going to get a squared, and this is going to get a squared. And what I need to have happen is I need this to match one of these. Now, I'm going to mark a couple points that are real important. This is my vertex. My vertex in this case happens to be the lowest point, so it's a minimum, and it occurs at -3, -2. That's my vertex. And then I happen to have two solutions. My two solutions are at -4, 0 and at -2, 0. These are my roots, my zeros, my x-intercepts. So I could call these roots, zeros, x-intercepts, or solutions. And the last thing I want to talk to you about is I could cut this parabola in half right here. And this is my line of symmetry. And the line of symmetry for our class will always be x equal. Well, what does x equal? It goes through -3, that -3. So I need to see which one of these will give me that. So moving on, I'm going to go ahead and go to Desmos. I'm going to plug them in, and I'm going to look to see for, I'm going to look for this point here, and this point here. So I'm going to look for my vertex, and I'm going to look for my two roots. So when I try to go to my share screen, and the first one is parenthesis x plus 3. Make sure you use the squared minus 2. And it's like, that's close, but those are not right. My vertex is in the right spot. But you know what? Just because that's close, I'm going to go ahead and mark them and label them, and then I'll put the next one up, see if I get a better answer. Okay? And we know the vertex is in the right spot. Then we're going to try the next one. The next one is 2, then parenthesis, x plus 3. Oops. Squared minus 2. And we have the same vertex, which is good. And we have -4, 0, and we have -2, 0. So I can get rid of that first equation. First equation is apparently wrong. And we look at this, we have -4, 0. That was one of our roots. -3, -2, that's our vertex. And we have -2, 0. Hey, that's our answer. So the answer choice to number 21 is B. Once again, this should have said f of x equals x squared so that you would know that. And I'll go ahead and show, and if I had done that, we would have had this equation. But that's how I knew to put these little squared signs there. All right, appreciate you watching. Look forward to seeing you on the next one. Thank you.